let's talk about some basics of trigonometry that Calculus 1 students need to be successful. Now, you do need to have some basics out of geometry in order to understand fully what's going on in trigonometry. And it's really just the simple things, like for instance, all angles within a triangle add up to 180 degrees. The largest angle is always opposite the largest side of a triangle. The smallest angle is opposite the smallest side, for instance. A right triangle, which is what we talk about mostly in trigonometry, is a triangle that has one 90-degree angle. If it has an angle that's larger than that, it's obtuse. If all angles are smaller than 90, then it's acute. And terms like that, those are, important things to understand from geometry. And then another thing from geometry that's really important is the Pythagorean theorem. And in fact, when we take the concept of the Pythagorean theorem and combine it with some of the other ideas in geometry, that's sort of where trigonometry comes about. The Pythagorean theorem, of course, is the theorem that says the sum of the squares of the two shorter sides of a right triangle is equal to the square of the hypotenuse. And the hypotenuse is, of course, the one opposite the 90-degree angle. So, for instance, when we are working with trigonometry, we often have some special triangles that are needing to be understood so that you can kind of have a basis for most of what we do in trigonometry. And that's our 45-45-90 triangle and our 30-60-90 triangle. So if you understand where these come about, so for instance, let me take an equilateral triangle. Okay, I'll draw it as best I can. All right, and if it's an equilateral triangle and we know that all angles add up to 180 degrees, then we know that each of these angle measures has to be 60 degrees. Okay, now if I were to divide this into two separate triangles, one thing that would happen is this would make two different right triangles, because certainly the way I've drawn this, I can make sure that that is perpendicular to the baseline. And this angle measure would bisect into 30 and 30. Now, this is the basic triangle that we use in trigonometry, the 30-60-90 triangle. But if you'll notice, I've also got these side lengths that are listed here. So where do these come from? Well, the place where they come from is this. Now, you can set any side length you want, but the one that makes the most sense is to set the side length to 2 for the equilateral triangles. So this would be 2, this length over here would be 2, and then these base lengths down here would each be 1. And that gives me two sides of a right triangle, which means using the Pythagorean theorem I can solve for the last side. And it just so turns out to be square root of 3. So the ratio of sides for a 30-60-90 triangle, it's really important to just know that ratio of sides is 1 square root of 3, 2. All right, and then a similar thing, if I start with a cube, and I say that that cube has length 1 on one side, which means inherently all side lengths are 1. Now, if I divide it as well, like this, so initially all of the angle measures are 90-degree angles. But if I divide it with the bisector of this form, then each of these is going to be 45 degrees. So what happens there is I end up with this basis for a 45-45-90 triangle. The two side lengths that I have so far are 1 and 1, and I can use the Pythagorean theorem to figure out the last side length is the square root of 2. So the ratio of sides there is 1, 1, square root of 2. Okay, so far all of this is based in geometry, which we pretty much only used degree measure for geometry. And for a lot of trigonometry, but not all of trigonometry. In trigonometry introduced radian measure. In calculus, It's really only radian measure that we ever use. You can use degree measure in application problems as long as you know to convert to radians before you actually do any of the calculus part of the applications. So you need to know how to work with radians. All right, so to work with radians, the key thing to understand is that pi radians is equal to 180 degrees. And if you say just pi, you don't have to actually specify that it's in terms of radians because it's in a unitless measure, which is what's important about that number. The 180 degrees is in a unit measure of degrees. So you always have to make sure you convert units before you do any operations with it. Radians are unitless, which means you don't have to do any conversions. You can just work with them directly. That's why we use them in calculus. Now, if pi is equal to 180 degrees, that's basically a straight angle. So what that means is if you divide pi by 6, that would give you 30 degrees. Because if you just divide both sides of this equation here, you end up with pi over 6 is equal to 30 degrees. All right, pi over 4 is 45, pi over 3 is 60. These three conversions right here, you really just need to have those memorized. Probably along with, of course, pi is equal to 180 degrees and pi over 2 is 90 degrees. It's really good to just have those known. Okay, so this is the quadrantal angles. Well, I guess technically the other quadrantal angles would be 3 pi over 2, which is 270 degrees. And then 0 and 2 pi are quadrantal angles, and they are equal to 0 degrees. Okay, now that's your quadrantal angles and your angle measures in quadrant 1. That's what you want to focus on, okay? Because you can figure out everything else in quadrants 2, 3, and 4 based off of what's happening in quadrant 1 and go from there. All right, we'll get to that point. Let's keep establishing some basics. Now, the most basic things that you need to understand comes from what's known as right triangle trigonometry. And it's just the basic definitions of our trig functions. And those definitions can easily be memorized with the help of the mnemonic SOHCAHTOA. All right, so SOHCAHTOA tells me that the sine of an angle measure theta is equal to the opposite side of the triangle divided by the hypotenuse of the triangle. So if here I have some angle measure theta, the opposite side is this one, the hypotenuse is this one. I just divide those two sides and that defines the sine of angle measure theta. All right, if I want to define cosine theta, so cosine, so CA-TOA, it's AH, so adjacent over hypotenuse, so it would be this value over this value. So tell you what, for instance, if I wanted the, all right, so this is the 60 degrees, so that would be the pi over 3 measure right here. If I wanted the cosine of pi over 3, if I had this triangle and that ratio of sides set up, it's the adjacent side over the hypotenuse, so it's just 1/2. If I wanted the sine of pi over 3, sine of pi over 3 is the opposite side, which is root 3 over 2. Root 3 divided by the hypotenuse, which is 2. All right, and then tangent is going to be opposite over adjacent. In this case up here, the tangent of pi over 3 would be root 3 over 1, which would of course just be root 3. Now, those are your main three basic trig functions, and SOHCAHTOA tells you how to define those based off of a right triangle. The remaining, you just kind of need to know as inverses. So cosecant is the inverse of sine. So instead of it being the opposite side over the hypotenuse, it's the hypotenuse over the opposite. Secant is the inverse of cosine. Cotangent is the inverse of tangent. Okay? So you need to understand how that works and be able to come up with values of trig functions based off of your quadrantal angles or your values in quadrant 1 if you need to. All right, based off of your, these right triangles here, these special triangles. Okay, identities. If you went through trigonometry, you know for certain that there was a lot of identities. You'll need some identities in a calculus class, but not necessarily every single identity that was ever presented. The ones that you will definitely need, all right, you need the reciprocal identities. Okay, you need to know that cosecant and sine are reciprocals of one another. This one and this one are basically the exact same formula. It's just telling me that sine and cosecant are reciprocals. The next one tells me that secant and cosine are reciprocals. And the last one tells me that cotangent and tangent are reciprocals. You just need to know that, okay? Your quotient identities. You need to know that tangent is sine over cosine. And if you know that, that's great, because you also then would know that cotangent would be cosine over sine because it's the reciprocal. Your Pythagorean identities. You absolutely need to know this one. Sine squared plus cosine squared equals 1. And thankfully, I'm pretty sure I've never met a single person that left trigonometry not knowing that. But then there's these other two. And pretty much everybody I've met that left trigonometry fumbles on these on occasion, okay? So here's the thing. The good news is you don't have to randomly guess at what these are. If you know the first one, you can just say, all right, for instance, sine squared x plus cosine squared x equals 1. And if you don't remember one of the others, just divide everything through by either sine squared or cosine squared. It doesn't matter which one you do, but you have to do the same function for each. All right, so for example, if I do everything divided by sine squared over sine squared is 1. Cosine divided by sine, that's going to be my cotangent. Oops, having trouble writing today. Cotangent squared x. 1 over sine, that is my cosecant. And if you'll notice, what falls out when I do that is one of these other two. So if I had divided through by cosine squared, I would have ended up with this one. So as long as you know the first one and you know your reciprocal identities and your quotient identities, you can come up with the other two, no problem. All right, sum and difference identities, I don't think that you use enough in calculus that you have to really make sure you have those memorized. Good to know where to find them if it's necessary, but I'm not really certain that it's necessary to have them memorized. All right, double angle identities. Certainly, sine of a double angle happens from time to time, and cosine of a double angle is sometimes helpful. Of any of the three, I would say make sure you knew sine of a double angle. Tangent of a double angle doesn't really happen all that often. I've really very rarely seen it in a Calc 1 class. So I would say in that order, sine first, then cosine, and tangent if you want it. Now the next group I've called the power reducing formulas. These are really helpful in Calculus 2. So if you go on into Calc 2, these are great formulas to have on hand. Calc 1, they're not really necessary. Your negative angle identities, these are occasionally helpful, but I really don't use them as is. So I wouldn't really put much time into memorizing them. So the things I've highlighted aren't that many. So that's the stuff that you basically really need to make sure you know so that you can be successful here. Now, the main thing that we use trigonometry for in Calc 1 is evaluating trig functions at different angle measures. And it's almost always the angle measures that are deemed special angles around the unit circle. So your things like pi over 4, 3 pi over 4, 5 pi over 3, stuff like that. And again, the ones that you need to know for certain, how to absolutely evaluate sine and cosine at your quadrantal angles and have memorized sine and cosine in quadrant 1. Okay, so I would definitely take some time to memorize sine and cosine at those points. All right, and even if you don't, you can still get along just fine, but it would make your life a little easier if you have these memorized. Okay, but if you know these basic ones, you can find your way around pretty easily for all 6 trig functions at every single special angle around the unit circle. Okay, so just the basis of the quadrantal angles and the special angles in quadrant 1. Now the quadrantal angles, if you forget them, it's pretty easy to just quickly sketch a unit circle like this. And you need to know that each coordinate pair, x, y, on the unit circle defines the cosine of the angle measure and sine of the angle measure that you're currently on. So at 0, for instance, this point on the unit circle would be 1, 0. That would be its xy coordinate. This point right here would be at 0, 1. That's its xy coordinate. And of course, it's pi over 2. So I could say cosine of pi over 2 is the x coordinate of the point on the unit circle at pi over 2, which would be 0. All right, sine of 0, well, that would be 0. And that means any of your quadrantal angles for sine and cosine are all just either 0, positive 1, or negative 1. But this little quick sketch right here can tell you how to evaluate all of your quadrantal angles. And if you have to draw that out every time you do these, there's no shame in it. It's just going to be a little bit slower to get work done. But it's more important to get the work done slowly than to just randomly guess and make mistakes along the way. So if you have to write these kind of things out to answer, that's fine. But, you know, I would definitely take the time to try and get them memorized for the quadrantal angles and the special angles in quadrant 1. On the next page, I've provided you a complete unit circle, and that unit circle has all the angle measures around the unit circle from 0 to 2 pi, and listed the x and y coordinates for each value. So if you needed to evaluate, say for instance, cosine of pi over 4, you just need to know that each coordinate on the unit circle defines the cosine of the angle measure that coordinates with that point, and the sine of the angle measure that coordinates with that point. So if I want cosine pi over 4, here's my pi over 4 line. I want the x coordinate, so it's square root of 2 over 2. If I want sine of 7 pi over 6, then I just find where 7 pi over 6 is, and sine is the y coordinate, so it's negative 1/2. If you have a filled out unit circle, it's really very easy to answer any of the sine or cosine or tangent, secant, cosecant, what have you, all the way around. It just takes some time to draw out a unit circle, and if you're taking a test, you generally don't want to spend time trying to draw out an entire unit circle before you start the test. If you have your quadrantal ones, your quadrantal angles memorized, and you have quadrant 1 memorized, then notice this. So this is the pi over 6 line in quadrant 1. This right here, notice it's 5 pi over 6. All right, it's not the exact same angle. These are called reference angles to one another. They both form a reference angle, like if I dropped a right triangle to the x-axis. they both form a reference angle of pi over 6. All right, but also notice 5 pi over 6 could be written as 5 times pi over 6. So that tells me that this is a reference angle of pi over 6 because it literally is a multiple of pi over 6. Regardless, if I look at the coordinates associated with that, root 3 over 2, 1/2. The exact same coordinates occur over here. It's root 3 over 2 and 1/2. It's just the x is negative. That's the only difference. If I look at the angle measure that is a reference angle of pi over 6 in quadrant 3, that's going to be 7 pi over 6. Notice it's literally 7 times pi over 6. All right, that takes me to this point right here. It's negative root 3 over 2 and negative 1/2. The same values, just positive and negatives are different. And same thing happens in quadrant 4. These are all called reference angles. And if you understand the concept of reference angles, then it makes it a whole lot easier to answer what's going on in the remaining quadrants instead of having to memorize every single sine and cosine value around the entire unit circle. Okay, so let's try a different reference. All right, let's try the pi over 4 reference. So the pi over 4 reference in quadrant 1, root 2 over 2 for both x and y. This is 3 times pi over 4, so that's the reference there. Same thing, it's just negative on the y coordinate, or sorry, on the x coordinate. And then down here, the x and y are both negative, but the same values. And here, same values, different signs. Okay, but one thing you might notice here is all of the coordinates for the x in this quadrant are positive. All the coordinates for y are negative because this is the positive x direction and this is the negative y direction. Should have wrote that the other way around. So positive x, negative y. If I travel 2 points in quadrant 3, well, this would be the negative x direction, and in quadrant 3 I would also be going to negative y. So notice all of these coordinate pairs are negative, negative. And then in quadrant 2, all the coordinates are negative and positive, and then quadrant 1 are positive and positive. Okay, so the only thing you need to know is the reference angle for quadrant 1 and whether or not the value is supposed to be positive or negative. So it comes down to a nice mnemonic, which is all students take calculus. What that means is all 6 trig functions in quadrant 1 are positive. So just in quadrant 1, everything's positive. In quadrant 2, sine is negative. So that means sine and cosecant. All the others are positive. Sorry, I said that the opposite. Sine is positive. All the others are negative. So sine and cosecant, because they're reciprocals, they're both positive. In quadrant 3, tangent, cotangent are positive. The remaining trig functions are negative. In quadrant 4, cosine and secant are positive, and the remaining are negative. All right, so I've made a mess of that, but hopefully that gets across to you how you can go about using reference angles to help you evaluate those trig functions. All right, so let's try some. Okay, I'm going to try and do this without a unit circle altogether. All right, so sine of pi over 6. This is one of my values that are in quadrant 1. So these I just need to have memorized. All right, sine pi over 6, that is 1/2. And you can go back and check off of the unit circle just to make sure. All right, so here's pi over 6. Sine is the y coordinate, so 1/2. All right, b. cosine of 2 pi over 3. All right, so this is not in quadrant 1. Okay, but here's something that can help. I can say that this is cosine of 2 times pi over 3. So this tells me my reference angle. All right, so it's going to be the same thing as cosine pi over 3. All right, so cosine pi over 3, that's going to be 1/2. And it's really just a matter of, is this going to be positive or negative 1/2? So the 2, that's where that comes into play. So I need to figure out what quadrant I'm in. All right, so one thing that I know is that I'm not in quadrant 3 or 4, because for that to be the case, the ratio, like right now, 2/3, this is less than 1. So something less than 1 times pi is going to give me something that's smaller than pi, which means it's smaller than 180 degrees. The only thing it can be is in quadrant 2. All right, so then all students take calculus. Sine values are positive in quadrant 2, so that means cosine is negative. So cosine 2 pi over 3 should be negative 1/2. And let's just check. All right, here's 2 pi over 3 in quadrant 2, just like we expected. Cosine is the y, or the x value. So there you go. Tangent of 7 pi over 4. Okay, so first off, just think of this as tangent 7 times pi over 4. So that reveals the reference angle of pi over 4. All right, now tangent, you do also have to sort of think of that in terms of sine and cosine, unless you have some of the tangent values memorized, which is even better. But if you don't, that's fine. You can still say it's sine of 7 times pi over 4 over cosine of 7 times pi over 4. And you just have to figure out what these two values are and go from there. All right, so sine pi over 4 is root 2 over 2. Cosine pi over 4 is root 2 over 2. So this is going to eventually be 1, but it could be positive or negative 1. And we have to determine that with the 7. So we need to know what quadrant we're in. So 7 pi over 4. So 7 divided by 4 is, a ratio bigger than 1. So that means I'm going to be in quadrant 3 or 4. So I kind of have to figure out which one it is. And along the way, you start learning some tricks. Like, for instance, if I go up here and look at the different measures here. Pi over 4, then 3 pi over 4, because 2 pi over 4 would be pi over 2. All right, so it goes to like odd jumps. So 1 times pi over 4, 3 times pi over 4, 5 times pi over 4, 7 times pi over 4. So that means that's going to put me in quadrant 4. Lots of different ways of figuring that out, but you need to have some way of doing it. In quadrant 4, all right, then it's all students take calculus, so the cosine values are positive and everything else is negative. So this results in negative 1. All right, one thing that I kind of know is tangent at pi over 4, it's always 1. And then therefore, all I have to do is figure out 7 pi over 4 is in quadrant 4, and then tangent is one of the remaining ones. So there are faster ways of doing this, the more that you know, but I'm giving you kind of a baseline of figuring things out. All right, secant pi over 3. So for secant pi over 3, ask yourself this. What's easier than secant pi over 3? Don't ask yourself, oh man, secant, I give up. What's easier than secant? Well, easier than secant is cosine. So it's 1 over cosine pi over 3. Let's ignore the 1 over and focus on cosine pi over 3. Well, cosine pi over 3 is the quadrant 1 angle of cosine. So we should have that memorized. It should be 1/2, which tells me that this is 2. So secant pi over 3 is going to be 2. And you can check that off of the unit circle, but let me show you how. So pi over 3 is the angle measure I'm interested in. I want the cosine value to start, but I'm then going to take its inverse to get the secant. So the inverse of 1/2 is 2. All right, cosecant 270. All right, so once you get used to how radians work, degrees start becoming the kind of foreign one, It's not quite so easy to tell what's a reference angle and whatnot. Honestly, I think it's a lot easier to just convert everything back to radians and work. So instead of answering what's going on with cosecant of 270, let's see what's going on with, so cosecant and sine. 270 is 3 times pi over 2. So I'll write it that way. All right, that's a quadrantal angle. So it's the quadrantal angle which is pointing downward. And so the y value would be -1 there, x value being 0. So this is 1 over -1, which is -1. Cotangent, 5 pi over 6. Again, just ask yourself what's easier than figuring that out. Well, let's see. So first off, tangent's easier. So I'll make it 1 over tangent. And then it's 5 pi over 6, so 5 times pi over 6. So I just need to first figure out what tangent of pi over 6 is. And it might help to kind of go off to the side and say, all right, so tangent is sine and divided by cosine. All right, so these are the quadrant 1 values. So sine pi over 6 is 1/2, cosine pi over 6 is √3 over 2. So that means this is 1 divided by the square root of 3. So this would be 1 over the square root of 3, which is odd. I get it, but it is what it is. We'll simplify. And then this multiplier of 5. So it's smaller than the 6, which means I'm in quadrant 2. All right, so then that tells me, because I'm in quadrant 2, all students, so sine is the only one that's positive, so tangent is going to be negative. So this would be -√3. And you can check that off the unit circle. So if we go up here to 5 pi over 6, so here's 5 pi over 6, and then cotangent, you're taking, for cotangent, it's cosine divided by sine, so it's the x over the y. The denominators of both of those are 2, so everything kind of cancels to just the numerators, which would be -√3. So it's not like I'm zipping through these things. So if you have them all memorized, that's great. You can zip through them. But as long as you have a means of figuring them out as you need them, that's perfectly acceptable. All right, now the next few here we have the arctrig functions, which just means to go from the ratio back to the angle measure. All right, so it's just the opposite. And again, you can ask yourself, like, what's easier than that? Well, here's something that's easier. Just know that there's some angle measure that exists. And instead of saying the arcsine of this ratio gives me that angle measure, you could say -√3 over 2 is the sine of that angle measure. Because if we know our values in quadrant 1, all right, so then that would mean that this would be a base angle measure of, for √3 over 2, sine would be pi over 3. All right, so that would be in quadrant 1. Now, this angle measure can't actually be in quadrant 1 because it's a negative value. All right, so that means that this is going to be in either quadrant 3 or quadrant 4. Now, there is a restriction on arcsine to where the measures are supposed to be in quadrants 1 or quadrant 4. So technically, we should answer with the quadrant 4 angle of -pi over 3, but perhaps the more useful angle is going to be the one that rotates not negatively, but rotates positively, and that would be the angle that's coterminal with this, so if I just add 2 pi to it, then that would bring me to 5 pi over 3. So that would be completely equivalent to the angle 5 pi over 3. And it just kind of depends on your application what the final answer should be. Oftentimes it's the one that's corrected for the quadrant. All right, arc cosine of 1/2. Again, that means there's an angle measure whose ratio of sides is 1/2. So we need cosine of that angle measure is going to be 1/2. All right, well, cosine being 1/2, this would tell me this would happen at an angle measure of pi over 3. All right, so you have to have those special angles memorized in quadrant 1 in order to be able to do these in reverse. That's why it's important to have at least those memorized so you can kind of associate the angle measures here for the arc trig functions. All right, and then for cosine, for arc cosine, the angle measures are supposed to be in quadrants 1 or 2. All right, so this is in quadrant 1, so that's fine. This is perfectly okay. Arc tangent, all right, that gets a little bit trickier because with arc tangent, what we're talking about there is, looking at what's happening with the ratio of sines and cosines. So you kind of have to take all that into consideration. But one thing that you can know is that if the tangent of a value is 1, it means that sine and cosine are the same. And so when sine and cosine are the same, you're at a reference angle of pi over 4, because those are the only places where sine and cosine agree. So reference angles of pi over 4. And because this is a positive one, and the values of tangent or arc tangent are supposed to be restricted to quadrants 1 and 4, this is perfect. That's a great answer. Your application may need you to correct for that in some way, but in this particular case, this is fine. All right, arc cosecant of 2. So this notation right here, so cosecant to the negative 1 power. That means an arc cosecant, just like if I had written arc CSC. That would mean the same thing. So you have some angle measure theta whose cosecant, force of habit, whose cosecant of that angle measure is 2. Now, the question is, cosecant. What's easier than working with cosecant? Well, one thing that's easier than working with cosecant is sine. So 1 over sine is going to be 2. Or what's easier than that? Sine is equal to 1/2. Okay? This is what we need to be able to solve. So this tells me if sine is 1/2, then that is the pi over 6 value in quadrant 1. All right, so then that means that this happens at pi over 6. So the arc cosine of 2 is going to be pi over 6. There we go. So you need to know the basics. Get the stuff memorized that I said to get memorized, and that will very much give you an advantage when you run into things that need trigonometry along the way. All right, the last thing that I've listed here are graphs of trig functions. And you don't really need to do a bunch of graphing with trig functions. It's just good to be able to have a conceptual visualization of trig functions graphs. And for me, it's mostly because sometimes I'll just forget what the value of, even in quadrant 1, a trig function is. It happens, it's not something that we use on a daily basis, so it's easy to forget these things. And it's good to have lots of different ways of remembering what these things are. And I find the graph to work out well for me. So quadrant 1 goes from 0 to pi over 2. And if you'll notice, the graph of sine is increasing. So it's getting larger in value. And if you go through the different values along the unit circle, you've got 0 and 1 at quadrantal values, root 2 over 2, 1/2, 3 over 2, root 3 over 2. These are the only values that you see along the entire unit circle. So your answer is going to be one of these, or possibly undefined if it's like undefined or does not exist. Whatever you want to write there is fine. If it's like tangent at 3 pi over 2, for instance. Okay, but here's the thing. It's basically one of these values. And if you put them in increasing order, it would be 0, then 1/2, then root 2 over 2, root 3 over 2, and 1. And if you're in increasing order, they kind of hit the angle measures in increasing order as well. So the angle measures associated would be 0. This one would be pi over 6. This one would be pi over 4, pi over 3, and pi over 2. So if you kind of understand that, well, you can really get a very quick list as to what the values of sine are. And then if you know the values of sine, well, cosine are just decreasing values. So for the same order of the angle measures, you just reverse the order of the numbers up top. And that's going to give you your cosine values. And, that's kind of a quick way of, like, even if you're just second guessing yourself as to what it is, I just kind of think to myself, all right, I need the pi over 6 value for sine. Sine is an increasing one. So it's increasing, that means the 1/2 is going to happen first. So then 1/2 is my answer. So, just different ways of approaching the recall of information is helpful. Last thing, tangent. The graph of tangent is, one that you could just kind of understand is multiples of like negative pi over 2, multiples of pi over 2 except for 0 have asymptotes, okay? And when you do arctangent, it's really helpful to understand that when you have an inverse, you're flipping the graph about the line y equals x, okay? So this is the result of that graph flipped about the line y equals x. Now the thing is, if you flip all of these graphs, you end up with another set of values down here, for instance, and another value set up here. And you don't have a unique answer for every single input. So to make sure you have a unique answer for every single input for arctangent, you have to restrict yourself from negative pi over 2 to positive pi over 2. And that's the same reason why you do quadrants 1 and 4 for sine and quadrants 1 and 2 for cosine. It's just when you invert that graph, you flip it, that is, about the line y equals x, in order to make sure you have unique values, you have to stay within those boundaries. So that's really the only reason I'd even want you to know about the look of the tangent graph or the arctangent graph, is just to know what those boundaries are for, arc-trig functions. And that pretty much wraps it up. Hopefully that gives you a good solid basis for the types of things you would need to know for a calculus class in terms of trigonometry.